In this video, I'm going to work out problem number 14 from the review for topics 1.1 to 1.14. So the table above provides data for 7 ordered pairs. Which function type best models the data in the table, linear, quadratic, or cubic? Explain your answer using characteristics from the data in the table. So if we're looking at the table, notice it looks like that my y values start to decrease. So they're going down, and then once we hit about 1.2 or 2.1, it looks like my values start to increase again. Okay, so this looks like it would be a quadratic function because the y values decrease and then increase around t equals 5. So again, it looks like my y values start to decrease, and around t equals 5, it looks like it switches to increasing. So that may be our minimum or the center of the graph. And it does look that these are roughly symmetrical. Okay, so they do look symmetrical. The data looks roughly symmetrical. Around t equals 5 as well. Oh, actually, that should not be a t, that should be an x. Let me make sure I use the right variables. There we go. Okay, now write an equation. So that's where we go to our calculator. We're gonna go to number 1, a new document. No, we don't wanna save. Number 4, to add a list in spreadsheet. Next to A, we're gonna type in X. And next to B, we're gonna type in Y. Then we're gonna go ahead and enter our data. Okay, so from here, I want to double check to make sure that it is a quadratic function. So we can do control doc, add a graph, number 2. And then we can go to menu, number 3, where it says graph entry edit, and we can add our scatter plot, which is number 6. Next to X, we're gonna type in X. Next to Y, we're gonna type in Y. And when I look, I don't see everything, so I can go ahead and fix my windows, so number 4, and I can do my window settings. And my X values, it looks like the lowest is 0. The biggest Y value looks to be 10, so I'm good with that. Or sorry, X value. My Y values, I'm gonna go from 0 to like 40, I'm gonna go to 45 just to give it a little bit of wiggle room. And then I can press OK, and notice that I do get what looks to be a quadratic function. Okay, so I can go back to my list and spreadsheet document, and I can do menu, 4-1, quadratic function or quadratic regression is number 6. I type in X, I type in Y, I have my F1 right there, and then I have my equation. So there's my A, my B, and my C. So AX squared plus BX plus C. It also has that right here for you if you forget. So I'm gonna go ahead and write this down. Remember, you need 3 decimal places for each of these. So I have Y equals 1.509 if I round, X squared minus 15.138x plus 39.997. So we should get that right there. Now, what we can also do to double check is we can go back to the graph and you can do menu, number 3, number 1, go up and press enter, and you should see that our graph goes through our points. Okay, now we want to know what is the residual for the point whose coordinate, x coordinate is 6.1. So remember, residual is equal to actual minus the predicted. The actual comes from the table, so at 6.1, the actual is 3.7. And then the predicted comes from using our model, so I'm gonna do y of 6.1, and then we can go to our calculator. So once we go to our calculator, we do need to add a new document, so Control Doc. We're gonna add number 1, a calculator screen, and we're going to do 3.7 minus F1 of 6.1. Press enter, we get our residual right here. So I'm gonna write it down to 3 decimals. You can write more is better, but you can't do anything less. So just because there's not a lot of numbers, I'm just gonna write everything. But again, you need a minimum of 3, so negative 0.085, negative 0.086, or just write the whole thing because it's better to be safe than sorry, okay? And so because our residual is negative, that means that this is an overestimate, okay? So that's how you will use the calculator for the upcoming test. So make sure you're comfortable using the calculator because you will not get any help with pressing buttons on the calculator.